Hi, this is a new chapter on probability. So I'm gonna go through 11.1 and 11.2 as well as 11.3. So the first thing is going to be chance of probability. Then I will go through theoretical probability. All right, so chance, the introduction for probability is basically telling you that probability is a percentage ranging from 0% to 100%. 100% in integer is actually 1. So basically, if you have 85%, it's actually a decimal, 0.85, when you divide it by 100. So that's why you will see here probability is between 0 to 1. All right? Now, one thing to know is favorable outcomes is something you want. So let's say we have a quiz, multiple choice. In one question, you want to get correct, right? So what's your chances? 1 out of 4 is your chance of getting correct. 4 choices in total. And number 1 is called favorable outcome. 4, on the other hand, is possible outcome. The total possible outcome. So you can pick A, B, C, and D, but only one of them is correct. So favorable is 1, and 4 is the possible outcome. Obviously, it doesn't have to be correct. Let's say you want to get it wrong. What's your chances? 3 out of 4. So 3 becomes favorable to you, and so on. So that's the meaning of the 2 words. And you're just going to answer the question. A card is randomly selected, right? I think they just want you to list down the possible outcomes. So you're just gonna list down these. That's the possible outcome. For number 2, R, O, G, and B are the possible outcome. Okay, so let's just move on. This part is super easy. Let's go with some more difficult questions like this one. Numbers selected 5 to 10 inclusively. Inclusive means including. So 5, 6, 7, 8, 9, and 10. Moving on. So write down the possible favorable outcomes for selecting an odd number. So we can have 3, we can have 5, 7, 8, 7, 9, 11. These are odd numbers. No 13 because 13 is out of the range. Okay, now let's move on to the harder ones. Theoretical probability. First thing is memorize the playing cards over here. And then the dice. Make sure you know these. These are very important. So example 2 over here. There are 28 chocolate bars in the box. 12 of them are milk chocolate flavor. A chocolate bar is randomly selected. What's the probability of getting milk chocolate, right? So you can write this P bracket milk chocolate. So this is the notation or shortcut way of writing probability of milk chocolate. Then there are 12 favorable to you out of 28. So you just have to simplify this fraction. We usually have our answers in fraction. So 12 divided by 28 in fraction is 3 out of 7. So that's the final answer. Number 2. Now over here, engineer has 3, 6, 8 letters. What's the probability of getting a G? So PG, 1 G only out of 8. That's the final answer. How about for B? You want to select a letter E. How many E's are there? 1, 2, 3. There are 3 E's out of 8. And this is the final answer. Again, try to simplify if you can. But these 2 you don't have to. Moving on. 30 red balls and 25 green balls. Find the probability of getting a red ball. So P, R, or red, is equals to, there are 30 red balls, but how many are there in total in the bag? 30 plus 25, right? 30 plus 25. And if I put in colors, you would see what's happening. That's what's happening. So when you simplify it, make sure you properly, maybe calculate the bottom part first so you don't mix it up. 30 over 55, and then simplify the fraction. 30 divided by 55. If you put it all at once, you might miss the bracket. So if you want to calculate this all at once, make sure there's a bracket down below. You want to do that first. Or else it's going to do divide first. 30 divided by 30, which is 1. 1 plus 25, 26. You're getting the wrong answer. You're not getting a fraction. Anyways, so this fraction is 6 out of 11. That's your chances of getting a red ball. Now, for the green ball, actually the green ball is the opposite of red here. There's a shortcut way of doing this. If you want a shortcut way, you can actually do 100% or just 1 minus. 1 is 100% in probability world. 1 minus your fraction, 6 out of 11. So you're going to end up with 5 over 11. The longer way, of course, you can do it the normal way, which is 25 green balls over 55. You end up with 5 out of 11 as well. Okay? Now let's find a difficult question. So number 8, something you need to use your previous knowledge about. So a number from 1 to 10, there are 10 numbers in total. Find the probability of getting an integers greater than 4. So greater than 4 is 5, 6, 7, 8, 9, 10. That's 6 numbers. So probability of greater than 4 would be 6 numbers out of 10. And simplify this is 3 out of 5. Okay, so sometimes they ask for odd number, prime numbers, right? Odd numbers are, you know what, odd. Prime numbers are basically numbers you cannot divide any other number except for itself or 1. So 2 is a prime, 2 is a prime. 3 is a prime, 5, 7. 9 is not a prime because I can divide 9 with 3. That's a different number and not just 9 and 1. The rest of them is dividing itself and 1. 7 and 1 for example. 11 is a prime. 16 is not because 16 can be divided by 4, 2, 8, 16, quite a lot of numbers can be divided there. So that's not. 19 is a prime. And so on. So you're just basically counting how many of them are prime divided by the total number of numbers you have. Total amount of numbers. Alright, these are just in a different form. So there's a lot of type of question for probability. I think the concept is easy to grasp. It's just how well you understand the question. Okay, let's go with playing cards. So this is my last question. A card is randomly selected from the probability of drawing a number card. So there are 10 numbers. Oh, A is not a number. A is the letter, right? So there are 9 numbers and there are 4 shapes. 9 times 4 shapes divided by 52. Your probability is what? Yep, 9 out of 13. So that's it for the video. It's okay. That's all for the video. Just let me know if you have any questions. Bye.